Hey guys, it's me again, and we are going to cover Unit 3, Polynomial Functions Review for your final exam in this video. This is quite a long section. There's a lot to cover, so I apologize in advance if this is going to be a long video, but it's worth it, so let's do it. First example, we are solving by factoring. Now, to factor, this is what we would call the difference of two cubes, because 8 and 27 and x cubed are all perfect cubes. So the pattern, remember, we have a small set and a large set of parentheses. And our three symbols are same as the problem, opposite of the problem, always plus. So same, opposite, plus. And then all we have to do for the first set is take the cube root of each term. So the cube root of 8x cubed would be 2x, and the cube root of 27 is 3. Now, the first term is the first term squared. So 2x times 2x is 4x squared. And 3 squared is 9. So the last term squared goes in the last spot. Now that middle spot, we just multiply these two together. So 3 times 2x would be 6x. And we're done. That's the factoring step. Now, of course, the solving, we would just set each term equal to 0. And we would get x is equal to 3 halves and a negative 3/4 plus or minus 3i root 3 all over 4. If you're asking me how I did that in my head, I didn't. I already worked it out. But that was just quadratic formula or completing the square. For this particular problem, I would use quadratic formula. And we already did that in the last video, so there's no need to do it again. Number 2. This we would do factoring by grouping. Whenever you have 4 terms, that's the first thing you want to check. So we would have x squared, and then that leaves us with an x minus 2. The GCF of this one is a negative 9, leaving us with an x minus 2. And remember, the insides must be the same. Since they are, we can take our GCFs and put it together. So x squared minus 9. And then our x minus 2. But wait, x squared minus 9 is the difference of two squares. So we can have an x plus 3, an x minus 3, and an x plus 2. All equal to 0. So x would equal a negative 3, positive 3, and a negative 2. Now, for all of these examples, I want you to remember the whole point of solving these different types of polynomial functions is we learn that they always match up to something in the graph. So we could type that in the equation and check it out. Special note, I screwed that up for a second. I copied the minus 2 wrong as a plus. So we should have a positive 2. All right, anywho, let's go. This one is just an old school factoring trick. What multiplies to a negative 4 but adds to a negative 3. But since we go 4 to constant, when we factor, we do it the exact same way, but we put x squareds instead. But that would just be an x squared minus 4 and an x squared plus 1, because a negative 4 times 1 is a negative 4, but they add to a negative 3. Difference of two squares right here, so we have an x plus 2, an x minus 2, and then our x squared plus 1. Set each term equal to 0, we should get x is equal to a negative 2, a positive 2, and a plus or minus I. Again, we already talked about solving with square roots in the last video. That's how you do it. Now I'm only going to do one of these because this is just multiplying. When we raise to the third power, that's just 2x plus 5 times 2x plus 5 times 2x plus 5. And we only multiply one set at a time. So if we were to multiply these two together, that would give us 4x squared plus 20x plus 25 after we combine our like terms. So, and then we would just multiply by 2x one more time. And after we, and our 5, and we would distribute all that, we would combine our like terms one last time, and we should get 8x cubed plus 60x squared plus 150x plus 125. Now, of course, you can use Pascal's triangle if you want to, but there is no need. This you would just do x minus 3 in parentheses 4 times. You would FOIL once, FOIL a second time, and then put those all together and FOIL it one more time. Or, again, you can use Pascal's triangle. We're not going to cover this one. We're just going to tell you that your answer should be x to the 4th minus 12x cubed plus 54x squared minus 108x and plus 81. Okay? So, moving right along. Now we're going to go talk about synthetic division. Not only is synthetic division a form of factoring, it could also tell you if something has a solution or if it's a root or not. So we're going to divide this by x plus 5. Now you can use long division, but synthetic division was the really fast method. So we start with our highest, and remember you're never allowed to skip. So x cubed would be a 1, because our leading coefficient. And then we have a 5 for the coefficient of x squared, negative 2, and a negative 10. But remember, x plus 5, we set that equal to 0 and put the solution out in front. Okay? Now, we always bring down the first term. But then the pattern is a negative 5 times what's down at the bottom, 1, is equal to a negative 5, and we put it right up there. Then we add these. 5 plus a negative 5 is 0. Now don't freak out. It's okay, because a negative 5 times 0 is just a 0. Negative 2 plus 0 is a negative 2. Negative 5 times a negative 2 is a positive 10. Negative 10 plus 10 is 0, and it goes away, and we have no remainder. Now remember, since we are dividing by x, x cubed divided by x is x squared. So this represents our x squared column. So we have 1x squared plus 0x's minus 2. That is our solution. But again, it's really cool that we have no remainder, because that means it is a root. Now, the next example is the same thing. I just want to set it up for you. This one would have a remainder. We would have a negative 3, but I want you to remember there is no x cubed here. So when you skip over a term, you must put a placeholder. So we have 1x to the 4th plus 0x cubed plus 3x squared minus 2x plus 5. Okay? I wanted to make sure I showed you the setup so you know to look for a 0. And after you did all the work, we would just bring down the 1. And then, of course, we would have a negative 3, negative 3. That would give us a 9 and a 12. And that would give us a negative 36 and a negative 38. And a 114 and a 119. Now, that right there is your remainder. So to write our answer, it would be x cubed. Again, starting 1 below. So we have a minus x, or 3x squared, plus 12x minus 38, plus our remainder over what we are dividing by, which is x plus 3. Okay? So let's take that to a more important level. Is x plus 2 a factor of this given term? And also, is x minus 8 a factor? I'm going to discuss 2 different ways to do that problem. The first way I will discuss is using synthetic division, of course. We just got done with it. So x plus 2 would give us a negative 2. Our coefficients would be 1, negative 3, negative 19, 27, and 90. Now remember, what I just talked about in the previous example, bring down the 1, negative 2, that's a negative 5. Multiply those two, we get a 10, that's a negative 9. Multiply those two, we get an 18, leaving us with 45. Multiply those two, that's a negative 90, and we have no remainder. So yes, it is a factor because it leaves us with no remainder. But there's another way we could have done that problem, and it's graphically. So if we were to type this function into y1 of our graphing calculator and click graph, we would see something that looks a little bit like this. Now, more importantly is our x-intercepts, and I want you to remember that x-intercepts represent solutions to this polynomial function. So there's one at a -3, a -2, a +3, and a +5. So if we were to go back and look, -2 is a solution. And since -2 corresponds to the graph, we could also say, yes, -2 is a solution on the graph, or one of our x-intercepts. So there's two different ways you can explain it. Go with the easier one, in my opinion, but if you forget what the easy way is, you of course can do that as well. Now, we could do synthetic division. Again, we would just put a +8 out front. But if we have a +8 out front, I can tell you after you do all the work, you will have a remainder of 1650. So you could say no, x minus 8 is not a factor because when using synthetic division, we have a remainder. Or you can say that 8 is not on the graph. So if 8 is not an x-intercept, it is also not a factor or solution to this problem. Okay, so there's two different ways to check. I like the calculator way because it's fast and it's slick, but you can do it any way you want. All right, moving right along. This example here is to help you analyze graphs and functions. So it says sketch the graph and then write in factored form. So if we were to type this into Y1 of our calculator again and sketch the graph, we're going to get a little sketch that looks like that. Now, of course, the most important aspect to this is the x-intercept, which we know is going to be 2 after you check it out inside your graphing calculator. So if x is equal to 2 and we're supposed to write this in factored form, remember this is simply synthetic division. We just use a 2. And then 2 skip to 0, -3, -10. Again, it's because we skipped over the x squared. Bring down our 2, that gives us a 4, and then 2 times 4 is going to give us an 8, and that's going to give us 5 times 2 is 10 with no remainder. So writing in factored form, we have x minus 2, and then 2x squared plus 4x plus 5. That is factored form. Now, listing all zeros, this is the last cool thing. Remember, this is an x cubed, which means we have 3 possible solutions, but we only see one is real. So that automatically should tell you that you're going to have 2 imaginary solutions after you solve this. So of course we're going to have x is equal to 2, but then we have to set this part equal to 0. Again, I would use the quadratic formula, and that would give you a -1 plus or minus I root 6 all over 2. Again, you can take the time to go watch the quadratic video part again. We need to try to get through this as quickly as we can. Now, this one right here, I'm going to set up a couple of them for you, and I'm only going to go through the work for one of them. But this is where we're working backwards. So what you want to do is set all of our parts or solutions equal to x. But then remember, we are working our way back to 0. So we would set this guy already as x because he's already equal to 0. We would add 2 to both sides. That would give us x plus 2 equals 0. Subtract 3, that would give us x minus 3 equals 0. And then we just take what's equal to 0 and we put it in parentheses, and we're good. Okay? So that's how you work with these. You just set them equal to 0, or get them back equal to 0. That's the trick. So for this one, we would have x is equal to 4, and x is equal to 3i. This would be x minus 4 equals 0, but we can't do anything with this yet because we have an I. To get rid of an I, we square both sides. That would give us x squared equals a -9. Because remember, I squared is a -1. So 3 squared is 9, I squared is a negative 1, leaving us with a negative 9. Now we add that back to the other side, and we have our 0. And this is x minus 4 times x squared plus 9. And then, of course, standard form is when we multiply it all out. I know I didn't do that in the last example. I'm trying to save time. But we have f of x is equal to. And then, of course, we have to just multiply it out, or FOIL it if you want to call it that. X cubed minus 4x squared plus 9x minus 36. Okay? And that's how we do all of these. The last example is a little bit trickier. The negative 3 obviously comes from an x plus 3. But then this, we have an x is equal to 2 plus or minus the square root of 3. Remember, plus minus doesn't matter. It always comes in a pair. Subtract that 2 back over to the other side. So that's x minus 2 is equal to a plus or minus the square root of 3. But now you have to wrap these in parentheses and square them. So that's the part everyone makes a mistake with. X minus 2 quantity squared is x squared minus 4x plus 4, and that's equal to 3. And then that would give us x plus 3 and an x squared minus 4x plus 1 after you subtract that 3 back over. And then, of course, to get your final answer, you would just multiply it out, giving you x cubed minus x squared minus 11x plus 3. Okay? Number 13 goes to regressions and determining what type of regression you need. So remember, this goes into L1 of your calculator, that goes into L2. That's where we click the stat button and go to edit and just edit our L1 and L2. Now we have linear regressions, quadratic regressions, cubic regressions, quartic regressions. There's different kinds of regressions we can do with our calculator. But the important thing is how do you determine which one we would use? And that's the finite series. So you ask, how do you get from 22 to 3? And that would be a negative 19. How do you get from 3 to 4? You add 1. From 4 to 1, we would subtract 3. 1 to negative 6, we subtract 7. From negative 6 to 7, we would add 13. And then once we notice that it's not the same, we do it again. How do you get from negative 19 to 1? You add 20. And then we would subtract 4, add 20. Still not the same, so you do it again. 20 to negative 4 is negative 24. And negative 4 to negative 4 is 0. Negative 4 to 20 is add 24. Again, still not the same. Negative 24 to 0 is we add 24. 0 to 24, we add 24. Hooray, we finally figured it out. It took 4 levels. So this is a quartic. So now you just use your graphing calculator to find a quartic regression, and k of x is going to be equal to x to the 4th minus 6x cubed plus 9x squared minus 3x plus 3. But the calculator does all of that work for you. Now this next example, this is just writing rules with transformations. We've done these plenty of times. So the rule of G means we have taken f of x, which is the simple x cubed, and we did some transformations on it. So remember, the cube and the x are not going to change, but the location kind of does, because our horizontal shift goes inside, opposite of what we think. Our vertical shift goes on the outside at the end, and our vertical stretch or compress goes in front as a multiplier. So since we have a vertically stretched scale of 3, that just means we put a 3 in front. Translation of 4 left means we have a plus 4 on the inside because it's opposite of what we think. Okay, we would typically associate left going to the negative direction, but it's opposite. Finally, 2 down is a minus 2 at the end, exactly the direction you would think it goes. Okay? So number 15 is just opposite. So the 1/2 tells us that it is a vertical compress by 1/2. The -5 on the inside tells us that it was right 5, and the +6 tells us that it's up 6. Okay? Now, the other thing from the one before that we need to talk about is a reflection over the x-axis. The only thing a reflection over the x-axis does is makes it negative, but we don't do that in this example here because it's not stating that it's negative, so there is no reflection over the x-axis. Okay, so that's how we do those two examples right there. Sketching with solutions is really simple. Remember, 3 distinct real, cubic. So all of these are cubic, so they have 3 possible. So when we have 3 distinct real, remember, a cubic looks like this. So when we have 3 real, it's 1, 2, 3. Now yours does not have to look like mine. The only thing yours has to do is cross the x-axis 3 times, giving us 3 different real solutions. When we have 2 distinct real and 0 imaginary, keep that in mind. It means it hits and bounces off once. Now, we could have drawn that in other ways. I could have gone through over here and bounced on the second one. It wouldn't have mattered. What matters is that you bounce once and go through another time. And that gives us 2 distinct real and no imaginary. Now remember, here's why. Imaginary solutions must come in pairs. They absolutely must come in pairs. So if we did 3 possible minus 2 distinct, we don't have room for 2 imaginary numbers because that would give us a total of 4. So if we don't have room for 2, we can't have 1. We can't have 3. You can never have an odd number. They always come in pair. So if there's no room for 2, we don't have 1. Finally, we have 1, and it just means it goes down but never comes back. That is an example where we would have 1 distinct real and 2 imaginary solutions because we have room for 2. We have 3 possible minus 1. We have room for 2. So we're good. This last example here kind of wraps up everything that we've talked about with graphing all semester. End behavior, remember, that means as x goes to negative infinity, which we know that's negative infinity for x. Here's positive infinity for x. Here's positive infinity for y. And down here, of course, is negative infinity for y. So our end behavior, as x goes to negative infinity, it's going down to negative infinity. And as x goes to positive, the graph is still going down, so it's going to be negative infinity for both. Domain, because it goes right and left forever, that's all real numbers. But remember, for range, we see that it is never going to go above 5. So our range is y has to be less than or equal to 5. Okay, the graph never gets above 5. So that's how we read our domain and range. X-intercepts, of course, that's just where we hit the x-axis. That's a -6, 0 and a -2, 0. But the y-intercept is where it crosses the y-axis, so that's 0, -4. Okay, so that takes care of intercepts. Now, local maxes and mins versus absolute maxes and mins. A local max and a local min, we can have more than just one. So a max would be at the top of any curve. So we have -4, 5. And we have 5, -3. Those are absolute or local maxes. A local minimum would be at the bottom of any curve. And we only have one here. It's 2, -6. Now, something we had talked about before is an absolute. Now, an absolute only exists if we are talking about an even function. So it's going to be a quadratic or a quartic, and as we can see, this one is a quartic. So it never gets above here. So this right here is the highest point on the graph. that would be your absolute max. So negative 4 comma 5 is our absolute. Now see, we can only have one absolute max or min. But there is no absolute minimum because the arrows are going down forever, so you would just leave it blank or say none. Increasing intervals. This has always been a little bit of a challenge, but remember, it's increasing. We only talk about the x values. So remember, we're starting from negative infinity. We stop increasing once we get to negative 4. So that's negative infinity to a negative 4. And then it decreases. Now it's increasing again from 2 to 5. So we increase from 2 to 5. Decreasing is when we go top to bottom. Remember, we always read this left to right. So negative 4 to 2. And we're going to decrease again from 5 to positive infinity. Remember, if it's on the right side, if we're going to the right, it's always going to be positive infinity. Negative infinity always comes from the left. Positive infinity is always going to the right. For increasing and decreasing, of course. Last one for this video is our possible solutions. So remember, this is a quartic, so there's 4 possible. We have 2 real solutions. Now, imaginary is possible minus real if you have enough room for pairs. 4 minus 2 is 2, so we're good. All right, that was a very long unit. That's why this video was quite long. But hey, I hope you're finding it useful. This is Longo, and I'm out. See you, bye.